We're going to spend 2 days looking at composition of functions. So first a quick review for the warm-up. If f of x equals 2x plus 5, can you find f of 3? So let's do that first. So this means plug in a 3 for x. All right, so let's do that. So this equals 2, and instead of x, we'll plug in a 3, and then plus 5. All right, so we say f of 3 equals 6 plus 5, so f of 3 equals 11. So with function notation, saying, first of all, this is a function. For every input, there's one output. And when you input the 3, the output is 11. So there's using function notation. All right, slightly different than what this is asking for. This is saying, all right, the answer, the output is 13. Find the input. Okay, so let's do that. So we're going to say 13 equals 2x plus 5. In this one, we solve algebraically. We will subtract 5 from each side. We will get 8 equals 2x. We will divide by 2, and we will get x equals 4. All right, so one is you have the input, plug it in, find the output. One is here's the answer, find the input. So we looked at those yesterday. All right, so here's a problem of the day to kind of represent what is the composition of functions. So Kohl's has selected your class to help determine which process would be better for the store. A customer can turn in 2 different discount cards per purchase. Here are the 2 discounts. One is 30% off total purchase, and the other is a $10 Kohl's cash certificate. So the question here is, would it be better for the store to take the 30% off and then deduct the $10, or would it be better to deduct the $10 first and then reduce the total by 30%? Show work that verifies your decision or be able to explain your answer. So again, here are the 2 choices, and you want to determine which is better for the store. In other words, which one saves the customer less money. All right, so here it is. First option, 30% off, then deduct the 10. Or deduct the 10, then reduce the total by 30. So which is better for the store? Which saves the customer less, earns the store more? So you can think about that, and we'll have several students explain what they came up with and why. And here's the definition. So a composition of functions, or a composite function, is when the output from one function becomes the input for the next function. So the output for one function becomes the input for the next function. In other words, we're going to use the answer from the first function to get the answer for the second function. And there's this thing called function notation we've been using, and you'll see it written like this: f of g of x. So this is a composition of functions. We do one first, and then we do the next function. So that's what we'll spend 2 days looking at, a composition of functions. So let's turn this Kohl's problem into a composition of functions. Let's call the $10 off f of x, and let's call the 30% g of x. Let's write the function that represents each of these situations. Okay, so $10 off of a total would be like x minus 10 if 10 was our total. And then for g of x is if it's 30% off, instead of paying 100%, what percent are we paying? So I'm going to change this to decimal. So 30% is 0.3. And if we're not paying 30% of it, so we're not paying 100%, which is 1, we're going to subtract the 30%. So what percent are we paying? We're paying 70% if it's 30% off. So what I'm going to do is I'm going to write that as a decimal. So 30% off is we're paying 70%, so 0.7, of the total. Of means multiply, and I'm going to multiply by the total, which is x. Okay, so here it is. If it's 30% off, you're paying 70% of x. So those are the 2 functions. Now let's write the composition of functions that represents $10 off first, and then 30% off. Okay, so first I'm going to write f of x because that is first. And then once you find that answer, we'll take 30% off. So we say g of f of x. We do f of x first. Okay, so here's what it looks like. Okay, so f of x, I'm going to write x minus 10. And then on the outside, we're going to write g of x. So it's going to be 0.7 of our answer. So we're going to take 70% of our total minus the $10 first. Okay, so that's what it looks like. Let's simplify this, distribute, and this will be 0.7x minus, and 70% of 10 is $7. Okay, so there's what it looks like. Let's try the next one. The one that represents 30% off first, and then the $10 off. Okay, so this time we start with g of x. And then once we find that answer, we'll do f of g of x. Okay, so here's what it looks like. G of x is 0.7x. And then if we plug in to the x minus 10, there's that new x, but then we'll subtract the $10 off of that answer. So here's what it looks like. And if I put both of these in boxes, okay, so there's one answer, here's the other. We can see which one saves the customer more, this one, because you take 70% of a number and subtract 10. This one will save the store more because it saves the customer less. So if they take $10 off first and then take 30% off, it will save the store more money. So this is the option that the store would want to use if they wanted to save more money or earn more money, save the customer less. So there's an application of composition of functions, finding the answer to one and then using it to find the answer for the second. All right, so that's an equation. We'll do more of those. Let's look at composition of functions and tables. So here I have two functions, f of x and g of x. Evaluate each expression. We start on the inside, like order of operations. So here we're going to start at g of negative 2. So this means when the input is negative 2, what's the output? So here when the input's negative 2, the output is 1. So we're going to say g of negative 2 is 1. So I'm going to plug that in. And now we're going to find f of g of negative 2, which is 1, so f of 1. Okay, so we use one answer, which was the 1, as the input to our next expression, and we're going to solve that. So now find f of 1, and that is 2. So our final answer, we say f of g of negative 2 equals 2. So it's using one answer to find the next answer. All right, let's do the next one. Let's start with g of positive 2. Okay, so g of 2 is negative 2. So now we find f of negative 2. So now over here in our table over here, f of negative 2 is negative 3. So we say f of g of 2 equals negative 3. Okay, let's try the next one. I'm going to erase some of this. Okay, so let's now go for f of 1. Okay, so f of 1 means you plug in a 1. What's the output? It's 2. So now we're going to find g of 2. So g of 2 is negative 2. So we're going to say g of f of 1 equals negative 2. And one more. Let's find g of f of 4. So start with f of 4. So the f function, when the input's 4, what's the output? It's negative 1. Or I should say, now we want to find g of negative 1. So over here, that'll be negative 3. So we see g of f of 4 equals negative 3. Okay, so that's using tables to find a composition of functions. Okay, you can also do it using coordinates. So this is like a table except sideways. So let's take a look at f of 4 first. So when we look at f of 4, we find in the f function, when the input is 4, what's the output? It's 0. So now we find g of 0. So now look in this table. When the input is 0, what's the output? It's 6. So we say g of f of 4 equals 6. That's kind of messy. Let's fix that. Okay, let's do the next one. Let's do f of g of 3. So start with g of 3, which is 5. So now find f of 5, which is 11. So we say f of g of 3 equals 11. One more using coordinates. All right, let's find f of g of f of 7. So we're just going to do it one extra time. So start in the inside. F of 7 is 3. So now find g of 3. G of 3 is 5. So now we go back to the f function, find f of 5, which is 11. So we say f, f of g of f of 7 equals, did I do enough parentheses? Yep, 11. Okay. And last, can you do composition of functions using equations? So first review, find f of 2 means 4 times 2 minus 5. So 4 times 2 is 8. 8 minus 5 is 3. So f of 2 is 3. But now let's find f of g of 3. So you start with g of 3. So g of 3 equals negative 3 minus 3. So g of 3 equals negative 6. Now we plug that answer into the f function. So we say f of negative 6. And that would be 4 times negative 6 minus 5. And so that would equal negative 24 minus 5, which is negative 29. So we say f of g of 3. You plug the 3 in first, got an answer, plug that answer into the f function, you'll get negative 29. And last one, let's do f, or g of f of 4. So start with the inside function f of 4 equals 4 times 4 minus 5, which is 16 minus 5, which is 11. So now that becomes the input to the outside function. We want to find g of 11. So we plug in negative 3 minus 11, and so g of 11 is negative 14. And so the final answer, we say g of f of 4 equals negative 14. All right, so this is day 1, practice with compositions. We'll take a look at more applications tomorrow.